Welcome to The Explainer. I am absolutely thrilled to have you here today because we are about to embark on a truly mind-boggling journey. We're going to take all the incredible recent data pouring in from the world's most advanced telescopes and space agencies and use it to execute a massive cosmic zoom out. We're starting right in our own conceptual backyard, traveling all the way out to the very edge of the observable universe, and then bringing it all back home to look at the immediate future of human spaceflight. It's a crazy time to be following astronomy, and today we're mapping the whole thing out.
But hey, to ground ourselves before we launch into deep space, let's look at a really relatable backyard observation. If you step outside tonight and look up, you might wonder, why do stars twinkle but planets don't? Well, when you view them from space, both actually shine perfectly steadily. The difference from down here on Earth really just comes down to distance. Stars are incredibly far away, right? So they appear as single, tiny points of light. As that tiny pinpoint of light passes through Earth's turbulent atmosphere, it gets refracted and bounced around, causing that classic twinkling effect. Planets, on the other hand, are much closer. They appear as tiny disks of light to us. And because they have a wider apparent surface, all those atmospheric distortions essentially cancel each other out, making their light shine totally steadily to our eyes. It's just a simple visual cue that instantly tells you about the sheer, vast scale of space.
Okay, let's dive into this explainer. Here is our flight plan. 1. Scaling the cosmos. 2. Planets, worlds beyond ours. 3. Stars, the cosmic engines. 4. Galaxies, islands in space. And finally, 5. The next great frontier.
Starting right off with Section 1, Scaling the Cosmos, from local to universal. So, as you likely already know, an exoplanet is a world orbiting a star entirely outside of our own solar system. But you guys, the game is changing here. We are rapidly moving past the days of just watching a star dim slightly as a planet passes in front of it to know it's there. According to recent astrophysics updates, we are now standing on the verge of a literal breakthrough, capturing direct images of these distant, potentially Earth-like exoplanets. We're shifting from graphs and data points to actual pictures of alien worlds, which is just wild.
Just to set our baseline here, on one side we have planets. They're closer, they orbit stars, and as we just established, they don't twinkle when viewed from Earth. And on the other side, we have stars. These are the massive cosmic engines that generate their own immense light and heat through nuclear fusion. They are the anchors of the universe, providing the gravity that holds entire planetary systems together.
Which brings us to Section 2, Planets, worlds beyond ours.
You know, just when we think we actually understand how planets form, the universe throws us a major curveball. NASA's Transiting Exoplanet Survey Satellite, or TESS, recently revealed data on what astronomers are officially calling the puffiest planets ever found in the cosmos. I mean, imagine a planet roughly the size of Jupiter, but with just a fraction of the mass, giving it a density comparable to, literally, cotton candy. It is absolutely mind-blowing to consider that planets aren't just rocky spheres or ultra-dense gas giants. They can be these incredibly weird, swollen, ultra-lightweight anomalies just floating around distant stars.
Now, take a look at that massive 40x figure. Recent research on the interstellar comet 3I Atlas, which, by the way, is a wanderer just passing through from entirely outside our solar system, revealed that it contains 40 times more heavy water than Earth's oceans. But wait, it gets better. The James Webb Space Telescope actually sniffed the chemical signature of methane coming directly from it. This is a massive deal, because studying the composition of interstellar visitors like Atlas gives us direct, tangible clues about the ancient, distant origins of other planetary systems beyond our own.
Let's zoom out a bit to Section 3, Stars, the cosmic engines.
Before we look at stellar life cycles, I have to share this fascinating debate currently playing out in the astronomy community regarding a star called Zupanc-Mali. If you ask professional astronomers, they'll tell you the physics of stellar radiation dictate that stars simply cannot appear green to the human eye. They should look white, yellow, red, or blue, period. However, if you talk to passionate amateur skywatchers who spend night after night staring through eyepieces, a lot of them insist that direct human observation proves Zupanc-Mali does, in fact, have a very distinct green tint. It's just a wonderful example of how theoretical academic models sometimes clash directly with on-the-ground human observation. Keeps the field of astronomy incredibly vibrant and open to debate, right?
Speaking of stellar physics, let's look at the life cycle of our own local star.
Right now, our sun is in its stable present-day phase, but in about 5 billion years, it's going to exhaust its hydrogen fuel and expand into a massive red giant, completely swallowing Mercury and Venus. Now, for decades, it was assumed this fiery expansion would completely engulf and destroy Earth too. But actually, scratch that. Shockingly, brand new research suggests that both Earth and Mars might actually survive the sun's deadly red giant phase. The dynamics of the dying star might push the planetary orbits further out, allowing our charred, rocky core to just continue surviving in the dark.
Across the rest of the cosmos, our telescopes are tracking the lives and deaths of stars in totally unprecedented detail. Like, recent data suggests that the massive star Betelgeuse might go supernova imminently. And by imminently in astronomical terms, we mean within decades, not centuries. Meanwhile, the Webb telescope has just unveiled images capturing young stars across literally every single stage of their formation, giving us basically a complete flipbook of how stars are born. And the legendary Hubble Space Telescope recently spied a globular cluster that looks exactly like a dense, glittering starry chandelier. Our instruments are truly finally unlocking the secrets of stellar life and death.
Zooming out even further now, Section 4, Galaxies, Islands in Space.
And right in our own galactic backyard, we are seeing things we never, ever thought possible. Take a look at this massive new achievement from the European Space Agency. Quote, "This view from the Euclid Space Telescope is the largest and most detailed image yet of the galactic center. Euclid is currently capturing the crowded, chaotic, dust-filled heart of our Milky Way with a level of clarity that is totally unprecedented. We are finally mapping the very core of our home galaxy."
But the revelations absolutely do not stop there. Everywhere we look, long-standing cosmic mysteries are being solved. In a feat of resolution that is just hard to comprehend, Webb recently pinpointed millions of individual stars within the distant Cigar galaxy. Beyond that, the James Webb Space Telescope finally cracked the case of the so-called little red dots, which actually turned out to be early, highly obscured black holes. We also have thrilling new research showing how a distant galaxy had its spin completely stolen by a merger some 12 billion years ago. And by combining data from both Webb and Hubble, astronomers have revealed ancient, sparkling relics left over from our own Milky Way's initial formation. The cosmic web is literally untangling right before our eyes.
So we've gone to the edge of the universe. Now let's bring it back to Section 5, the next great frontier, returning to the moon.
Yeah, we've zoomed out to the edge of space, but now we've got to bring it all back home. To establish a permanent presence beyond Earth, we have to practice the mechanics flawlessly. And that brings us to NASA's Artemis III mission, slated to launch in 2027. Unlike the old Apollo missions, the flight plan here is incredibly complex. The mission will launch the Orion spacecraft and practice docking it with 2 separate lunar landers while still in low Earth orbit. While this specific test will not actually land on the moon, it is designed to strictly test the exact, rigorous capabilities and orbital maneuvers we desperately need to master in order to safely return humanity to the lunar surface and, this time, to stay.
Now, pulling this off requires unprecedented international cooperation. As the crew manifest highlights, joining NASA astronauts Randy Bresnik, Frank Rubio, and Andre Douglas is European Space Agency astronaut Luca Parmitano, serving as the Artemis III pilot. It is a truly unified, global effort to push the boundaries of human spaceflight. So what exactly are we preparing for after Artemis III? Well, the primary target is to build a human lunar base outpost by the end of this decade. But as we look even further into the solar system, scientists are proposing something straight out of a science fiction movie, a dedicated lunar quarantine facility. The idea is that as robotic probes and eventually humans return from Mars and beyond, we need a secure facility on the moon to safely examine these samples, ensuring we protect Earth from any potential invasive alien microbes before they ever reach our atmosphere. How cool is that?
2029. Let that number sink in. That is the target deadline for putting human feet back on the lunar surface and establishing our very first permanent outpost on a world beyond our own. This is no longer some abstract dream of the future. It's a fast-approaching reality, with hardware currently being built and crews actively training as we speak.
We've zoomed from the twinkling stars in our backyard to puffy cotton candy planets, dying suns, and ancient galaxies, all the way back down to the hardware that's going to carry humans back to the moon. But as we prepare to make the moon our permanent stepping stone, I want to leave you with this final, awe-inspiring question. What will we find when we finally set up that lunar quarantine facility or build our permanent moon base? What ancient cosmic secrets are waiting for us right under the lunar dust? Keep looking up at the night sky because the answers are coming way sooner than you think. Thanks so much for joining me on this explainer, and I'll catch you next time.